Hi, my name is Ramna. My personal blog is .netiq.com. You can follow my blog at facebook.com/.netiq. In this screencast, I'm going to cover the adapter design pattern. This design pattern falls under the structural design pattern. So I will start with a real world example. Uh, yes, if you see here, when I was in India, my laptop power cord looks like this, and it is means when I try to charge, but in India all the power plugs like power plug boards, it has a round circular inputs. So my power cord is expecting one circular metal and it has two vertical flat metals. It cannot directly fit into this power board plug because of this incompatibility. So in between we have something called this adapter, power adapter, which is going to no it is going to fit to this one side. This side is going to fit with the power cord, and this side is going to fit with the other side is going to fit with the Indian power board. So this adapter is going to help to in between power cord in between the power cord and power plug board, and it supplies the power. So because of this incompatibility they cannot talk each other, but this adapter is going to go in between, and they translate the one each other understandable way. So the power cord, this power adapter is going to really useful in between to means get the power charge. This is the best example to understand the adapter design pattern. Coming to the adapter design pattern definition, adapter pattern translates interface of a class into another interface of a class which clients can expect or clients can understand. If the client is expecting a method, means client is expecting a certain interface, I mean to say if it is expecting some method name, but the class actually where the implemented the logic is existed, that logic existed class does not have those methods. So in between you will write a adapter class. That adapter class have a client expecting method name. That method is going to actually talk with the implemented class. I will go to explain the UML diagram. Here we can understand better. This is my UML diagram for the adapter design pattern. Here the client is expecting some client wants to use some logic from this class. So it has some logic, get some data and get other data. Client wants to use that logic in his client class wants to use that logic, but due to some incompatibility, due to of the client implementation, it can the incompatibility of due to some incompatibility it is cannot directly use these class methods. The client is expecting some get qualified data. To maintain the consistency, he is expecting some get qualified data is the method name. Since the adapter does not have that, so the client class what it decided to do is it separated the get qualified data into a interface. So this method is going to be separated into interface. We need to separate into interface. This is the adapter interface. So we can write a implementation class, adapter implementation class, where you have implementation for like this method implementation. We have implementation for that method. So this method actually talking with this adaptive class, and it's going to use this logic, get some data and get other data, it applies something and it is going to use it here. So basically client is expecting the get qualified data. Since it does not have directly, so client separated this get qualified data in interface. That interface implemented class is going to deal with the adaptive class. So the client can directly create an instance of the adaptive implementation class and call that method get qualified data. In future you want to deal with another data source. That data source class might, if the same situation happens, if they don't have a direct approach and direct methods to get the what the client expecting, in that case you will write one more adapter implementation class. That class is going to deal with that. The perfect example in the .NET framework is data adapter implementation. If you see if you want to fill a data set, means the filling the data set with the data is the common functionality, everyone expect that. But if it is a different data source like SQL data source or Oracle data source, OLDB data source, and ODBC, we have different data sources to communicate. We have different approaches. So each data access layer have a different, internally they have a different methods. We don't know that different methods to different methods or different ways to do the filling of the data set. So to make it common, to make it common, and to make it standard, the .NET framework, they come up with a interface called iData adapter. Sorry, yes, iData adapter is the interface. So in a SQL, we have a SQL data adapter which is implemented the iData adapter. So it has a fill implementation, fill class, fill method implementation. This fill method is going to internally talk with some SQL DLLs that we don't know the actual what it is doing inside the fill method to achieve the fill functionality. The same way with the OLDB adapter, it is implemented the iData adapter. The fill is going to talk with the OLDB related stuff. The same thing with ODBC. But as a client, depends upon my need, I will directly go to create an instance for SQL data adapter, and I use the SQL data adapter fill. And if it is I'm dealing with the Oracle, I will create a Oracle data adapter. But everywhere I know that there is a fill method must exist. So it's, for me it is easy to deal with any data source because it's the same method, same way of creating the objects, establishing the connection, getting the data, because everywhere, even if it is a different data source, you have a same methods because they implemented the same interfaces. That way you have a consistency. Even in future, if you want to add another data source, then you can directly implement the iData adapter. Like DB2 data adapter is going to implement the iData adapter. It has also a fill method. So as a client, for me it is really easy to use the DB2 communication, establish the DB2 communication, DB2 data also, because the DB2 also has the same methods what the SQL data SQL has and OLDB has and ODBC. That way the programmer, or means the client who is expecting, it's very easy to deal with the new things. I will show you one example real quick how we can use this. Just I don't want to this let me see here. The manager's data is the one class. It has a get qualified data. My requirement is to find the qualified manager's data. Maybe some criteria is there. Whoever qualified that criteria, I want to list out all the qualified managers data. So I have a managers data. I have a method called get qualified data. So my client said if I want to use this, I just create an instance of the managers data class and call the md.getQualified data. And later they come up with ask for the find the employees qualified data. The employees is a big area. See, it is a actual adaptive class. It has a, we have a full-time employees and contract employees and some other employees. Each have it's a different methods. In overall, you want to find all the qualified employees. You don't have a direct approach. To use this in my client side, I need to write like this. Sorry, this way. This is the way. It like create a employee adaptive instantiation and calling the two methods like contract employees data and full-time employees data. Just imagine if we have another like departments wise qualified data. That department have a another maybe more methods, and you need to apply different logics to come up with the qualified data. So there is no consistency between in each set of the data. You are doing the same operation. Like in the manager side, you are doing the finding the qualified managers. In employees, you are finding the qualified employees. In department wise, you are finding the qualified. Means the basic functionality is this common, but you are using a different methods and different implementation. You are it's like, you know, it's, there is no consistency in code. So then how we can introduce the adapter design pattern in this case is, so I see that the get qualified data is, this is the, like, you know, it's a generic name, and I feel that this is the method I can, across the board I can use this. So I will separate it in an interface called iData. My iData has the get qualified data. So I'm just implementing the iData here already I implemented the get qualified data, so there is no need of implement because the interface has the same method. So since employee has a different methods, so I cannot there is no directly get qualified data. So I will write a adapter class called employee data. Here this is implemented of iData interface. So iData has a get qualified data. Internally I am creating the employee adaptee and I am doing this logic inside of the get qualified data. At the client side I have a consistency. I can directly call my employee adapter class like employee data instantiate, and I'm calling the get qualified data. Internally this is going to talk the actual implementation class that we called as adaptee in our UML diagram. Get qualified, this is going to talk with the actual class and it's going to return the client expecting. So in future if you are going to come up, you want to deal with the departments, even departments has a different methods, a number of methods, but you will have a department adapter class. That class is going to I implemented the iData means adapter interface. That interface method is going to actually talk to the your actual implementation class. That way you have a consistency. Then it's easy to extendable. Your means it's easy to extendable, easy to understandable. I hope I explained the adapter design pattern in a understandable way. And another thing is there is a close similarities between facade design pattern and adapter design pattern and repository design pattern. I will come up with another video to compare these three design patterns and when to use which one is the right to means right one to use in a right place. I will try to come up with in a different session. Thank you.